In the last class, we were talking about the concept of the supernode. Okay, I have submitted one example to you. Okay, though that was example was of some higher exercise that is related to the dependent source. Today, I will explain first of all the concept of the supernode with the help of with a circuit containing only independent sources. Okay, first of all, what is supernode? Again, let's have a revision. What is a supernode? If a voltage source, a pure voltage source or ideal voltage source means with no resistance connected in series with it, is connected between two nodes. Okay, then and the two nodes are being combined together to form a super node. Is it clear? And we used to write a single equation on that super node. Clear? So let's take one example through which we will demonstrate. Write down okay, so let us write down the question. So, how many nodes are there? Is there anything left? Yes, this much. 12 volt. Yes. Identify number of nodes. How many? How many? Everybody agrees? Let us mark it. 1, 2, 3, 4, and this is 5. Am I correct? Am I correct? Okay. Now, out of these 5 nodes, one of the node has to be made a reference node. Okay. So let this, I made this as a ground node. This fifth one as a ground node, and assign the values V1, V2, V3, V4 to the remaining nodes. So let this be V1. Let this be V2, let this be V3, and let this be V4. Clear? Now, is there any supernode you are seeing as per the definition? This. Is it clear? Between V3 and V4. Okay. So, we will combine these two nodes and we will call it as an super node. So, this became your super. Clear? So, I will write down the corresponding single equation at this super node. Is there any problem in this? Now, how to proceed? What is the voltage of this? What is the voltage of this? V4. Do you agree? Okay. Now, I can also write down this is higher potential. This is at lower potential. Okay. So, V4 minus V3 is equal to, do you agree or not? Or I can also write down V4 as 12 plus V3. Do you agree? Do you agree or not? So instead of V4, I will mark it as a V3 plus 12. Clear? Any problem in this? No. Okay. So now with this much of the background, you have how many node voltages now? Only 3 unknown voltages. V1, V2 and V3. So you should write down how many equations? 3 equations. Okay. One will be this at V1 node, another will be at V2 node, and another will be at this super node. Do you agree or not? So let us start with this. First equation. First of all, the KCL, Kirchhoff current law at this V1 node. How much it will be? How much will be? How much it will be? V1 is equal to 6 volt. Very clear or not? So again we got V1 is equal to 6 volt. No problem. Yes, any doubt in this? No. Now write down the second equation at V2 node. Huh? V2 comes out to be 12 volt. Okay, fine. This is the second equation we got. What about this equation? Now write down the corresponding KCL at the node V3. Assume, oh sorry, 2 kilo. This is 2 kilo. What else? Oh, this 1 kilo. Clear? So now write down the node equation at the V3. How much it comes out to be? Please one make correction. Sorry. Please make one correction. This is negative positive. So on this basis, how much is V1? Minus? Do you agree? Okay, fine, good. Minus 6 volt, correct. Is there any problem in this aspect? Should I repeat? Because this is how much? Ground. Ground means 0. So this is how much? At 0 potential. This is plus is at the 0 potential. Is it clear? The total difference between them is 6 volts. Definitely this is negative, means this will be at lower. Lower means which quantity is lower than 0? Only minus quantity. So it is not plus 6, but it is minus 6 volt. This is clear or not? Okay. Now I will write down the corresponding node equation at the super node. Okay. So first of all, what about this current? There will be one current through this also or not? How much it will be? V3 plus 12 minus 6. Is it clear or not? Okay, because we said that this will be assumed to be highest voltage. Is it not? Therefore, this is at higher potential and this is at lower potential. Potential difference between them, this voltage minus this voltage. This voltage is how much? V3 plus 12, and this voltage is how much? V1. So V3 plus 12 minus V. Is it V1? So V3 plus 12 minus, what is V1? What is V1? Minus 6 volt. Hence divided by 2 into 10 raised to power minus 3. This is clear or not? This term is clear. Next, what about this equation? Yes, speak out. Plus V3 plus 12 minus 12 divided by 2 into 10 raised to power minus 3. This is clear or not? Any doubt regarding this? Now next. I think so all the equation here, these nodes are clear. Plus at this node, this is a super node. We have to write down a single equation. Is it clear? So how much this will be? V3 divided by 2 kilo. Write down. V3 divided by, it is 2, no? 2 into 10 raised to power minus 3. What else? V3 minus V2 divided by 1 kilo. Okay, what is V2? What is V2? 12 volt. So it will be plus. Yes, if you have any doubt, please ask me. Rather than discussion, please ask me. Is there any equation left? Any term left? Any term left? What? V3 minus V1. Okay. Yes. Plus V3. What is V1? So minus minus plus 6. Or for more clarity, I write down minus 6 upon how much? 1 into 10 raised to power minus 3. All this algebraic sum is equal to 0. Now 10 raised to power minus 3 is in all terms, since it will be eliminated. It will be eliminated. Do you agree or not? So what is left? Solve the equation. V3 plus 18 divided by 2 plus V3 by 2 plus V3 by 2 plus V3 minus 12 by 2. What else? V3 plus 6 by 1 equal to 0. I think so LCM will be 2. And now you can solve it. How much it will be? Collect V3 terms. V3, 1, 2, 3, 4, and here it will be 6. 6 V3, I think so. Are you getting the same result? 18 minus 12, 6. 6 plus 12. Now V3 plus 12. This is V3 plus 12. Second last. This. V3 minus 12. Oh, this is 1 kilo ohm. Sorry. This is 1 kilo ohm. Oh, no problem. V3. So V3 minus 12, it will be 1. Is there any doubt? Now solve it. So how much you will get? V3 is equal to minus 6 by 7 volt. Clear? And now with the help of this, you know V1, you know V2, you know V3. Now if I ask current in any branch, say had it been my this branch, I would have asked find out the current through this. Okay, so what would have been the answer? How much will be the current direction is this much, means this is higher, V3 plus 12. Now suppose in the question you have been asked to find out the current this I. Clear? This current I means this is in this direction. Definitely this potential is, ये विभव हायर है और किसके कंपैरिजन में? इसके. तो इनका बीच में विभवांतर कितना होगा? विभवांतर कितना, पोटेंशियल डिफरेंस कितना होगा? V3 प्लस 12 माइनस V2. बंद करो, बैठो. So I think so if you are asked the current in any branch, okay, you can find out, is it not? Okay, suppose I ask in this branch, very clear, V3 divided by 2 kilo ohm. Okay, I ask in this branch, very clear, it is. Now if I mark this direction as this, then you say the V1 minus V3 divided by 1 kilo. The ultimate objective is that if you know the node voltages, you can find out the branch current in any part of the circuit. Is it not? Okay, so now I move to the yesterday's question where I have inserted and dependent source. Okay, you have to treat the dependent source in a similar way as that of the independent sources. Okay, the supernode concept will be true for not only dependent source but also for the independent sources, thereby meaning that if a dependent voltage source without any resistance is inserted between two nodes, again it will be treated as an super node. Okay, so let us write down the tomorrow's question. So I am writing down that supernode question. So what was that question? That supernode question last. Okay, it was this. Okay, I think so. Why you are making arrow? Instead of there should be polarity sign na, for Vx. Why are you making arrow? No, mind it. Whenever a potential is being shown, don't put the arrow like this girl is pasting. It is plus and minus sign. Okay, had I would have changed the polarity sign, the question would have changed. Is it clear? So be cautious in writing the polarity sign. In which direction the Vx has been shown. So again, see, look towards the question. Any data missing? No. It is having an independent source, a voltage source of 6 volt, and a independent as well as independent source. Now, what type of source is this? Is voltage dependent voltage source. Is it clear? So, and what is Vx? The quantity on which depend. This is the voltage drop across the 6 kilo ohm resistor. This is very clear or not? Now you have to find out the branch current. What was the branch current I have given you? In which current? 6 kilo ohm? 12 kilo ohm. Okay, fine. No problem. In fact, you can make it any as a branch current. There is no such question. Once you know the node voltages, you can find out any branch current. So let us say you have to find out the current through this 12 kilo ohm using nodal analysis. So first of all, you have to find out the number of nodes. How many nodes? 4. Okay. 1, 2, 3 and 4. Okay. This fourth node is made as an reference node. We are left with 3 nodes. Okay. V1, V2 and this V3. But my seat between V2 and V3, sorry, between V1 and V3, voltage source is there. No doubt it is a dependent voltage source, but a voltage source is there. Therefore, V1 and V2 will be combined to form a supernode. Is it clear? Now we have to write down the corresponding equations. Okay, first of all, before writing the equation, let us transform this. Okay, what is V1? What is this 2Vx? 2Vx is how much? V1 minus V3. Any confusion? Because this is plus sign, this is at higher potential, minus sign is lower potential. Therefore, the potential difference will be V1 minus V3. Okay, so how much you got? How much you want to eliminate V3? Enough. So V3 will be equal to how much? V1 minus twice Vx. Am I correct? Is it clear? So how many unknowns you have till so far? 3 unknowns again. No, 3 unknown. Vx is also unknown. Is it clear? So what is Vx? What is Vx? Vx is nothing. Drop across 6 kilo ohms. So I can write down it is V3. Is it not? It is 0. Is it clear? This drop is this much only. Do you agree or not? How much potential difference? V3 minus 0. This is the potential difference across the 6 kilo ohm, which we have assigned as an Vx. So Vx is equal to another equation we have got. Okay, now what we will do? What you will do? You will write down the KCL. Is it clear? First of all, this super node. What is the KCL at super node? Write down, speak out. This is V1 upon 12 into 10 raised to power minus 3. Am I correct? What else? Plus V1 minus V2 upon 6 into 10 raised to power minus 3. Any more equation here? Any more terms here? No. Now write down that corresponding equation at this. How much? V3 by which can also V3 can also be written as V1 minus twice Vx upon 6. Is it not? Or can I write down this like okay into 10 raised to power minus 3? What else? Plus V3 minus V2 upon 12 into 10 raised to power minus 3 equal to 0. In any doubt in this respect? Okay. Now what is next? What is next? Huh? Yes. Again we got V2 is equal to 6 volt. Clear? Now substitute V2 is equal to 10 raised to power, eliminate 10 raised to power minus 3 from all terms. V2 is equal to 6 volt. Okay, wherever V2 is there, substitute 6 volt. What else? What else? What else? Huh? V1 equal to 3? Are you getting this much? Everybody is getting this much or not? Now, I think so you have committed some mistake. What was here? What was here? V3. It was there? Okay. So, you write down here V3. And is there any Vx term here?
Just V3.
क्या what? हाँ वही, that's what I am saying ना. V1 by 12, this is correct. V1 minus 6 is equal to 6. This is second term. Then V3 by 6. Where it is coming? Yes. V3 by 6. Okay. And what else? V3 minus 6 upon 12. So how much you are getting? Tell me. How much you are getting now? Solve it. Vx, V1 and V3 terms, how much you are getting? Not Vx, I am just telling, because this equation is now in which form? V1 and V3. Is it clear? Please do not put anything, just give me the answer of this. How much you are getting in terms of V1 and V3? Everything is being replaced by V1 and V3. No Vx term is there. Okay. Now give me the result. Solve this. How much you are getting? This is V1 by 12. This is V1 minus 6 by 6 plus V3 by 6 plus V3 minus 6 by 12 equal to 0. Am I correct? Okay. Now give me in the result in the terms of V1 and V3. How much you are getting? Are you not getting any result? Just solve it. How much you are getting?
Solved. I have just eliminated V.
I want to give solution in this form. How much you are getting? You don't know how to find out LCM. 5 V1 minus is equal to 0 is equal to, how you are getting 18? Okay, 18. This is correct. Everybody is getting this much or not? Now, what is the second equation? V1 minus V3. V1 minus V3 is equal to how much? Twice Vx. Clear or not? And what is Vx? What is Vx? V3 divided by 6 into 10 raised to power minus 3. Okay, so I can write down here V3 divided by 6 into 10 raised to power minus 3, which come out to be like this. Oh, sorry. V1 minus V3 is how much? Twice Vx. And V3 is equal to Vx. Okay. So it will become twice V3. So from this what we get? V1 is equal to 3 V3. Substitute this here. Substitute this here. Okay. So how much you will get? V1? V1 is equal to how much? 9 by 2. Everybody is getting this much result? Just you have to rearrange the equation so that we are left with only the node voltages. Is it clear? While all the other terms are eliminated. Okay. Especially the dependent quantities we have to eliminate. Here the dependent quantities were what? Vx. We have eliminated it and ultimately we got V1 is equal to 9 by 2. So what is V3? V3 is equal to how much? 3 by 2 volt. Okay. Now with this much of the background, can I calculate this branch current? How much will be? V3 minus V2. What is V3? 3 by 2. What is V2? 6 volt. So 3 by 2 minus 6 divided by 12 kilo ohm. Is it clear? So how much it comes out to be? How much it comes out to be? Huh? So the branch current I comes out to be minus 3 by 8 milliampere. Is there any problem in this? Is there any problem? So now if I ask in any branch, suppose I ask in this branch, suppose I ask in this branch, or even ask in this branch, you can calculate it because all node voltage are known to you. Is it clear? It is not the question of the branch current, it is the question how you identify the number of nodes. Among the nodes, how much are the super nodes, then how you apply the KCL, okay, and after applying KCL you have to find out the corresponding unknown voltages, and then you can find out the branch current in any part of the circuit. Is it clear or not? Okay, so super node concept is clear, okay, and do you agree that it can be applied to both dependent as well as independent sources? Is it clear or not? Okay, now we move to our next portion. Let us do some more numerical, is it not? Let's have some more numerical. Okay, so write down. So in this question, I think so I have written all the numerical values. Yeah. Okay, so you have, yes. Okay, yes. 1 kilo. Mind it, this is voltage you have to find out. You have to find out V0. He's doing nodal analysis. Now see, this question is very good question, which contain a dependent source also and independent source also, and independent you have a current source also as well as a voltage source. Is it not? Now you have to solve, that is you have to find out this voltage, that is the drop across 1 kilo ohm resistance using nodal analysis. First of all, identify the number of nodes. 4. Okay, which one? 1, 2, 3, 4. What else? Which one? 4 or 5? 5. Which is fifth one? This one? These are all common node. Which one? This we have already taken. How many? Everybody agrees? How many nodes? 4 nodes. Okay. So one of the node is to be made as a ground node. Okay. Let us make. We are left with how many now? 3 nodes. Okay. Let this be V1. Let this be V2. And let this be V3. Is there any doubt? Now, what about V1 and V2? What do you want to say about V1 and V2? Forming and supernode. Forming and supernode. Okay, fine. No doubt. Okay, so how many equations you will write down now? Only 2 equations. Okay, the third equation will be for the unknown voltage Vx. Is it clear? So let us first of all find out the relationship between this node. This is at higher potential. Therefore, I can write down what is V2 minus V1 as twice Vx. Clear? And what about Vx? What is about V1? Vx? How much? V1. This is the voltage drop. Okay. How much is this voltage? V1. This is 0. Drop is how much? V1 minus 0. That is V1. Therefore, Vx is equal to V1. This is clear or not? Now, with this much of the background, we will write down the corresponding equation at each node. So, first of all, let's take the super node. Speak out. What can be the terms? First is will be the, I think so, minus 2 into 10 raised to the power minus 3. Current source going inward, therefore minus sign. What else? V2 minus V3. V2 minus V3 divided by, or are you not getting point? Is there any confusion? Okay, what else? Whole voltage is V2. Is it clear? So it will be V2 minus 4 upon 1 into 10 raised to the power minus 3. Is it clear? What else? Now comes to the V1. V1 by 1 into 10 raised to the power minus 3. What else? V1 minus divided by 1 into 10 raised to the power. Any more? Any more? No, that is another node, na? That we will write down at this node, na? So at present I am considering the super node. Do you agree or not? This I am considering only super node. So this is equal to how much? Do you agree or not? Okay, so simplify it. What you will get? Minus 2 plus V2 minus V3. What else? Plus V2 minus 4 plus V1 plus V1 minus V3 is equal to 0. Speak out how much it is coming.
V1 plus V2 minus V3 is
How much? V1 plus V2 minus equal to 3. Okay, this is equation 1, this is equation 2, okay, this is equation 3. Is there any problem? Now next, write down the corresponding equation at the node V3. What will be the equation? Speak out. One will be already minus 2 into 10 raised to the power minus 3. Current source is there going inward direction, this current. What else? Plus V3 minus V1 divided by 1 into 10 raised to power minus 3. What else? Plus. What else? V3 minus V2 divided by 1 into 10 raised to power minus 3 equal to 0. So solve it. How much you are getting? Is there any left? Nothing? Sure? Okay. So now rearrange it. What you will get? The fourth equation? Minus V1 minus V2 plus 2 equal to 2. This is equation number 4. Clear? Yes?
We put a negative sign over there because the V0 is indicating that the V3 is
No.
negative.
V0 is just a secondary thing that we will take into account when we solve all the node voltages. Is it clear? He is saying we are not concerned with this. This is the question polarity mark. Is it clear? When we solve all the node voltages, then we will say that he is asking V0 assuming V2 to be higher than V3. Means V3 has lower potential while V2 has. So once you find out V2 and V3, then say V0 is equal to V2 minus V3. Substitute the value. Had it been lower value, it will come negative. Is it clear? Okay. But the question examiner is saying, I want this V0 and I have given polarity to the V0 plus above and minus below. Clear? At present you need not have to consider whether it is plus minus. We have assumed all the voltages V1, V2, V3 at their point to be maximum. This is what I have given you the step, that whatever node you are considering, you will assume its voltage as a maximum voltage. Is it clear? So when I am standing here, V3 is maximum. When I am standing here, V1 is maximum. When I am standing here, V2 is maximum. You did not have to bother about it, what is given in the question. This is a question. The examiner is saying that I want this potential. Suppose a source is there, 12 volt. Clear? And I say V0 is equal to this minus and this plus. What is V0 value?
Minus 2.
I want V0 with given this polarity, then V0 will be minus 12. V0 will be minus 12. Okay. And if I ask simply like this, find out V0 with this much polarity sign, you will say plus 12. So it is the examiner polarity. It is not the question polarity. Is it clear? So once we find out V1, V2, V3 all, then we say you want V0 and you are giving this polarity sign. Okay, this is this. Clear? Okay. So how many equations we have found out? 1, 2, 3, 4. Okay. How many unknowns? 3. Can you find out the corresponding? Have you found out?
Yes, sir.
How much it comes out? V1 how much? 2 volt. V2 and V3. You got my point? Just solving the equation is there. Nothing else. Once you have found out all this, now what is the examiner asking? V0. What the question is asking? V0. And what is V0 as per this polarity sign? V2 minus V3. So V2 minus V3 is equal to V0. What is V2? 6 volt. And what is V3? 5 volt. So it comes out to be plus 1 volt. Clear or not? Okay. The polarity sign or the arrow marking in the question asked will be taken into account at the finish of the solution. Is it clear? When you find out all the node voltages, now you see in which direction current is being asked or in which polarity the voltage has been asked. Is it clear? Before that, you assume everything that node voltages which are under consideration, they are having maximum voltages. Is it clear or not? Okay. So I think so with this much of the background of the super node, the concepts are very much clear. And now there is no fear regarding the dependent sources. Generally, a fear happens in the minds of the student regarding the dependent source, and it remains after the completion of degree also. Is it clear? But with this much of the background and with this much of the delivery, I think so now you can solve any type of dependent, independent problem, and also the problem related to supernode. In our next class, we will take the mesh concept and the super mesh concept. Is it clear? In between, I will provide assignment also. You have to submit that assignment with your lab records. Clear? That's all.